Okay, we can turn to page 31. Okay, so page 31, we're going to be building off of these power series. Again, we're going to have these quiz over these power series formula on Wednesday. So again, the Wednesday quiz will look just like your interval convergence worksheet. The only thing I'm changing is number 5, which is just finding radius and interval convergence and being able to fill out convergence absolutely, conditionally, radius and interval convergence. So if you have questions about building out these formulas, I will have a help session tomorrow morning, 7:30, and Wednesday morning, 7:30, as well as going over these types of problems like number 5 if you feel like you need additional help. Okay. But any questions about Wednesday's quiz? And this will be no calculator. Okay, so we need we're just basically working on building out these formulas so that we can have these as a foundation for a lot of these problems that we need to do. Okay, so here are the main ones for just for reference. So if we look at number 1 here, if f of x is equal to the sum from 0 to 5, 0 to infinity, x to the 5n over n factorial, then f prime is equal to let's just find out the first few terms and then build out the derivative from there. So my first term is when n equals 0. So if I plug 0 in for n, I get x to the 0 over 0 factorial. Oh, by the way, 0 factorial is equal to 1. So I basically have 1 as my first term. Just building out each of the terms here. Next term is when n equals 1. So x to the 5 over 1. Next term is when n equals 2. So 5 times 2 is 10 over 2 factorial. And then next term is 3. So x to the 15th over 3 factorial plus dot, dot, dot. F prime, I'm just going to do power rule for each of these terms. 1 goes to 0, 5x to the 4th, 10x to the 9th over 2, 15x to the 14th over 6. Just going to do some cleanup here. Okay, I'm also going to build out the general rule. If I find the derivative of my general rule, that will get me down to f prime. So I would bring down the 5n. And then subtract 1 from the exponent. But I'm just going to clean this up as well as show my summation here. So I want my first term for f prime to be 5x to the fourth, right? So I think that will be the best fit if I were to start off at 1 instead of 0. And I can cancel out one of the n's here. So if I cancel out one of the n's, then this will go down to n minus 1 factorial. All right, any questions there? All right, number 2. Write the first 4 non-zero terms for the Maclaurin series that represents sine of t to the 7th dt. What can we start off with as our first step? Let's build out what? Sine of x. Yeah, let's build out sine of x, and then we can build out sine of x to the 7th, or t to the 7th, and then we can take the antiderivative using power rule. Okay, so we'll just kind of build it out, one piece at a time. So that means sine of t to the 7th just means replacing every x with t to the 7th, right? That's what we want to do. Replace every x with t to the 7th. Once I have sine of t to the 7th built out, clean it up a little bit more, then I can just, to take the antiderivative, I can just do power rule and then plug in my upper and lower bound. Well, the nice thing is just the x needs to be adjusted. The 0 will just go away. So okay, any questions? Okay, next page. Page 32. Let's try number 2. So number 2, see if you can write out the first 4 terms, or the first few terms for f of x, then find the derivative, and then build out the general term. Or you could go ahead and build the derivative of the general term and then just find the first 4 terms built off of the new summation rule. Mm-hmm. The factorial is just some number. So just like coefficient, it just kind of stays there. We're only finding the derivative of x. So if you want, you can think of it as 1 over n factorial times x to the 2n. If that helps, it makes you see that that n factorial is not going to make an impact. Yeah. But here, n and n factorial, right? I can clean up a little bit more into this form because I know that n factorial is equal to n times n minus 1 times n minus 2 times. And so if I can cancel out one of the n's, I can just stop here and call it n minus 1 factorial.
Well, I guess my question is then, how come sometimes I just see the factorial sign being gone? Well, I guess you're simplifying the factorial.
Yeah. Sometimes I'm simplifying it.
Okay.
Sometimes I'm leaving it, but I do want us to just be comfortable with both ways, because sometimes on the AP exam, if you're just asked to, if it's just free response, you can leave your answer unsimplified, which is great. But if it's multiple choice, you may have to do a little bit more cleanup to match one of your multiple choice questions.
Yeah.
So just be comfortable with. Sometimes if you already have an answer that's going to give you full credit, there's no reason to continue simplifying. So let's see. Next one I want us to do. Page 33, number 6. Everybody okay here? Page 33, number 6. So let me start off with something that we can build off of this, or that we can start as we can have as a starting point. This 1 plus x to the 7th, we can kind of looks like this 1 over 1 plus x. And if I have a 1 over 1 plus x, I can think of it as 1 over 1 minus negative x. The nice thing about this form is this is basically in the geometric series form. Your first term is 1. This kind of fits that a sub 1 over 1 minus r. If I can get that this to be in the form of 1 minus r, I don't want to change this overall value, but if I can write in this form, then I can see, okay, this is my common ratio. This is my first term. And then we can just use this to adapt and build out this 1 over 1 plus x to the 7. And if I get into this form, I can just build out my first few terms using my geometric series knowledge, right? My common ratio is negative x to the 7th. So I'm just going to multiply my previous term with negative x to the 7th. But it says write the first four non-zero terms for the function f. So if this is f prime, then the integral of 1 over 1 plus x to the 7th would be f of x. And to build f of x, we can just do power rule for each of these terms here. Okay. Any questions? Your homework will involve the odd number problems. So let's just see how much we can do. Let me kind of pace us through. So going back to page 32, go back to number 1. And then if you guys try it, I'll also show the answers and we can talk through each of the problems as well and kind of just get a head start with our homework. So okay, we can think of sine squared x as sine x times sine x. So if we start foiling out the first few terms, we should be able to convince ourselves, you know, what's the coefficient of x squared going to be once the dust settles? In this case, we're not going to have multiple terms that we have to worry about, because if we were, foiling out the first few terms in this binomial, we're going to see that once we get past the first term, our degree is going to be too high. And so we only have to worry about that x times x producing an x squared. Okay, number 3. Mhm.
X. Wait.
Sorry, at the end, all the variables should be in terms of x. I didn't make that change. Number 5, page 33. Okay, start off with what you know about 1/1 minus x. And you can start updating that to eventually get to your goal of x squared over 1 minus x squared. Okay, number 7.
On Wednesday, can we just write it as things we, yeah, so it's equal to like the second step. We just step. Or do you need to do a summation for the extra part?
Yeah, you can leave it like that. Yeah, you can write the first four terms. You don't have to write the summation, you can write the general rule. Yeah, is that what you're asking? Yeah. You can leave the summation out of on your quiz, but some of them do have summations, like the Maclaurin and the Taylor series. So, I mean, on the on my key here, I have the summation left out. So just write it down as memorize it as the one as what I've created on the key. Okay, we're good with 7. Go to number 9. And then finally, number 11.
We on the.
Do you have this formula sheet?
I did.
Okay, this was on this.
All right,
Just this.
just.
Yeah, so I just want to make sure we have this foundation before our test, which is next Wednesday, I think. No, sorry, it's I figure out what the date is for the test. Nineteenth. I'm gonna make it 19th. So next Wednesday.
I thought there would. This.
Right, which is this formula sheet.
Oh.
Yeah, this formula sheet will just be your place. Yeah. Okay, all right, let's finish up with 11. Build out your cosine, build out your 1/1 minus x. Once you get the polynomial Taylor power series for each of those, then you can start foiling out, and we only care about the terms that it's going to fall in that category of constant degree 1 or degree 2. I listed out more terms than I needed. But I did need to combine some like terms. So x squared minus x squared over 2 is basically x squared over 2. your homework tonight's page 28 to 36, just the odd number problems. And then start reviewing your worksheet, because this is going to be your quiz on Wednesday. So start building out and practicing all the different McLaurin rules there. Okay. Help session tomorrow, 7:30, and Wednesday morning, 7:30, if you want me to go over each of these rules with you individually. Okay. All right, come get your folks.
They can do on quiz tomorrow morning.
Let's get 100.
It's tomorrow and 88 and
The quiz is Wednesday.
I can get the 90, I just have to log in.
You got that? You got that?
Yes, sir. You got it too, man. You have
Like for, because I volunteered, so I put it today, something we would get something better. Have you found worse for?
Watch out too.
On what?
Sure. How many points did I got for my test for being late?
5.
5? Alright, so I got the 90.